so bibliographic data and text collections for some time, with the idea that our interest been bibliodata for a very long time, but then always the idea that we have to go back to the text collections and iterate between those. And we are very much a research group, so our first idea isn't to get the library catalogs perfect, which we would like, of course. But so we worked for quite some time on the English short title catalog, thinking about it and how to use that in research. And it's a unique opportunity because there's also 18th century collections online, which is about 50% of all of those titles that are cataloged in the ESDC. So we started now in this project and a bit earlier also, but working quite a bit, thinking what to do with the full text so that it can be, everything is potential metadata when it's systematic and so forth. So we've done, one thing that we've done is that we've run all the textual overlaps through this BLAST software, so that we have recognized all the overlaps in all of the works of the ECHO, which creates about 1 billion edges, which then can be used in order to see that how the texts are, who's quoting from whom, and so forth and so forth. So one thing that we did this reception reader based on it, where you can, if you're interested about a particular work, you can start actually looking at what kind of textual overlaps there are between other works in the whole collection, and then think that what relevance that might have. There's quite a bit of technicalities that goes into it, but I'll let now David, who has been great with us developing the actual interface. So David, you can do the honors of telling what we see in this slide.
Well, I can show you a little bit of the what and maybe explain the how, if necessary, but Mikko will tell you more about the why if you have questions. So here you can see what is called a bee swarm graph, which plots all of the reuse cases citing this book, and every dot is a case of this reuse. You can see from some other book talking about this Macbeth book. And then the x-axis is time, sort of shifts towards the red as it gets later. You can see there's more reuse and citations than earlier. And the y-axis is just the pages. If we look at one of these pages, this is a good example. You can see this particular sentence or passage being cited. And you can also browse through the page, you can browse through the book that's citing it, see what it's actually talking about. That's about it. This is for this demo. Maybe Mikko can tell you more.
Well, let me just quickly say that it's okay. You take Shakespeare's Hamlet here, and you
Macbeth.
Yeah, sorry. Yeah, okay, Macbeth, same thing. But so what do you notice? I mean, that knowing the kind of history of canonizing Shakespeare. So it was published in 1730s. This particular work that we're not looking at all the expressions and so forth of Macbeth, but that reception of, I mean, the overlaps between that particular instance and the other works. So what you notice is that earlier in the earlier part of the 18th century, it's not reused so much that it's not happening. But then you see the Samuel Johnson effect when you know later towards the 18th century, there's a huge bunch of textual overlap between the 1730 published Macbeth and then the later editions. And there's a lot of filtering happening behind this, so that we've dropped obviously all the other editions of Shakespeare and so forth, and that kind of thing. But if you think, I mean, that this is just one instance of thinking about the textual overlap. But if you think that in all kinds of other places it can be used, and also so that if we have IDs for the relevant textual overlaps. If there's like yesterday we talked about the text similarity a little bit, so that if there's a significant amount of textual overlap between different works, then you can think that, okay, this is something that could have its own metadata tag without that being exactly further information, but something that you can use elsewhere. And then thinking from the perspective that if you want to take statistical perspectives to the century, that's something you can do. Here, the idea, of course, is just giving the humanities people a chance to first find the instances easily that you would like, and then you start reading. And that reading part, going from the, if you want to use those metaphors, distant and close reading, that is very much happening here, and that's why I really like this. And also some of the colleagues that we worked on the Hume's essays reception case, for example, with people who are not digital humanities people, and they really thought that they didn't like digital humanities or whatever you want to call it, but then they changed their mind, which is always nice.
So that's the Helsinki part, mostly of the high-performance computing and historical discourse project. There's also a part in Turku, which is headed by Philip Ginter, who actually speaks Czech, I believe. So his PhD student, Emil, made this indexing. Basically, the ECHO has 200,000 books, and there's millions of pages as OCR text from the past decades of varying quality with a lot of noise in it. So they basically used an open library called Weaviate to index it, so you can perform some kind of vector search through all of these passages. And my understanding is it's chopped into 500 token chunks, and you can type in a certain phrase and see which of those particular sections is most similar to it. And the amazing thing is you can search it across languages. It's in English and some of the French books, but you can here, for example, try Czech. And then now it's doing the search, find some results that you see is talking about basically the same topic. If you're fresh, you can try it in a different language. You get very similar results. It's based on semantics rather than keywords.
But also, I mean, that if we think about, I mean, a lot of people doing this cross-lingual and semantic sort of a paraphrase type of ways of detecting things, and then Andre, who's not here now, I think, but anyway, the translation thing. I've been talking that with Philip that okay, well, let's start by looking at document level. That there is enough of the similarity across languages, which is a way of identifying that the book is actually the same, even so the language just becomes one variable. So that then they said, well, no, that's quite boring because it's so easy. So okay, fine, let's do it. I mean, we have a way of actually fairly easily detecting the translations in this way. So we don't have to be looking at the metadata. We go to the full text to do it. So I mean earlier, let's say a couple of years ago, always thinking that okay, let's just focus on harmonizing the metadata and use that. But now I'm kind of flipping towards the side that let's go with the full text first, and then, I mean, for many questions. We're also working on genre, sequential genre detection in the books. So why would you think that one document is one genre? And what if you want to label it 6 genres, what does that help you? Nothing. But if you're able to say that, okay, the beginning of the book was one genre and then it changes and so forth, like you have an essay collection and you can actually label automatically those essays. So based on the very much the same steps that have been taken in NLP, there's quite a few things that we are able to do now, and so this is all I think very recent. So the big people in Google and their well, the large language models, they are changing things, I think, and that's something that also we in the Bibliodata business we need to accept and go with that. You want to say something else?
Is there something in chat?
Yes, there is a question from Linda, but I think that you already answered this question. Would it find usage in other languages? Example, if Macbeth was directly quoted in the other language than the original language?
Yes. Why don't you go ahead then?
So currently there are two different mechanisms, right? This one is based on semantic vector search, and the other demo is sort of blocked here. But yeah, the other demo is based on just it's an algorithm for detecting protein sequences, and here it's applied to text. So I suppose here is almost the text overlap with some tolerance for noise, whereas the other one is based on meaning. And the next step perhaps is to run some kind of comparison within these sentences or passages based on meaning.
And the idea that if it, like a paraphrase detection, let's put it like that, and that you can do that multilingually. So then we can change that into the other one also when we have the data, but that's British data mainly, so it's English. There are some French and other language documents there, but mainly English. But in the end, I mean, that once we have, we should get more and more data in a machine operable form. I mean, that's a problem for a lot of languages and studying the history of literature in many languages that we don't have the data. For example, Finnish 19th century, we don't have the Finnish 19th century corpus in OCR form.
Yeah. Very good. Coffee.
Thank you. I would just like to ask thank you guys for the lightning talk, and would like to ask if there are some lightning questions, but if the coffee is, I definitely remember David from summer school, or it wasn't, from hackathon in Helsinki, and he's a record man in drinking coffee. So I could understand his need for the coffee, but maybe there might be someone from the audience who would like to pose a lightning question to this lightning talk. Yes, Sylvia.
I was just wondering, because I don't know if you know Manuel Burkhardt's work on the Victorian, and he was also looking at Shakespeare quotes, and so making a distinction between verbatim quotes and I think semantic paraphrase and change word order and so on, because so there are some phrases that Shakespeare uses that are used then in other texts and are not necessarily a quote of Shakespeare. It's just that they are saying something that anyone would say, right? So how are you describing?
So this first one, I mean, due to the fact that we are dealing with the OCR noise, the idea is that we detect more or less the same passages. So they need to be quotes that they don't have to be exactly similar, but and any kind of allusion or paraphrasing or something like that doesn't work here. But then the second one is doing that. So with the second one, that happens, but we haven't yet gone to we only have that search function now there, but that can be put here as well. Of course, then the number of data points explodes. I mean, that we have now 1 billion edges here. So after that, I don't know, we have 1 trillion, but that's okay. I mean, that's why we have CSC, But yeah, so that going towards that is what we want to do, and then one point for having this is we are very much interested to have actual work IDs that work. So that meaning that if I'm alluded to it, or did I say yesterday that if I want to know the development of David Hume's essays, there are many points of integration there along the line. So he publishes political discourses that become part of the essays. But if you just look at the titles when you are trying to figure out that which belong together, you can't notice that. But looking at that, if there's relevant textual overlap, we can create IDs where we have this information, and also that what is it that happens when like again, Hume, he first writes History of Great Britain, then he changes the name to History of England, but then he starts writing it backwards. Are these same works or not? And you know, that kind of, there's a lot of that kind of question when you start thinking about it. But with this text overlap thing, you can go quite far with that. And when you are there trying to look, you're not looking for sort of allusions or things inspired by, or it's not only for quote detection.
How do you store this 1 billion notes?
Yeah.
What is technology?
So, do you want to talk about where they, MariaDB, how they are stored?
How is it stored?
Yes.
So the BLAS is actually, they're all running on the big data engineering pipelines, and Eddo had extracted some of the data into more like a normal database, SQL database that you can query. And there are so many columns. They also included the text extracts. So if you include the text extracts, that's like terabytes, and it's very hard to query. So you just pulled out a few columns, so you can get which is the first document, which is the second document, and the character offset from the OCR to generate the highlights here, for example.
And then we have the offset information that's linked to those images, and then gives you that.
Yeah, because the big data pipeline queries, they take some hours to run each. Here, at least you can get some results within a few seconds.
But then we do have the text is separate, so if you have to do something with those snippets, then you can take them and like in a low filtered scale. But running anything with if you have all the text with you there, it's not going to work. It's just too much.
Fascinating job. Is it possible to explore the textual overlaps with the metadata of the books for further analysis? This is the one question. The second one is, how do you indicate the degree of overlaps on the visualization? I can't see the differences of the points from here, but perhaps there are different sizes of the notes.
Yeah, I mean, so we all the time use the metadata together, so that there are identifiers in place that we can use whatever we have. So that happens easily in a way. Here there are no sizes. It's just to indicate the kind of cluster and to which page things are going and what there is. We do calculations. So for example, that when working on editions, we have a couple cases ongoing where we are interested where the later edition has substantial additions to it compared to the earlier one. But to identify those, we'll just calculate it together because we know the length of the document, we know the length, overall length of the text reuses, so we calculate from there. So we get a percentage score of the overlap between the books, and we can calculate that between any item in the database, or just query so that we get all the. I mean, that here's the document that I'm interested in, and then I calculate all the overlaps there for those. But there's so many points already on that graph that it would maybe not work, but this is just the first prototype that we've done so far. So we're also thinking that towards which direction to develop it.
Thank you guys for your lightning presentation.